everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method part 3. So let's get going. Solve y double dash minus y equal to 1 plus e power minus x raised to the power minus 2, or d square minus 1 into y equal to 1 plus e power minus x raised to the power minus 2 using variation of parameters method. So here we are going to use another way of solving variation of parameters method. So let's see. We are given a differential equation of order 2. Given differential equation, y double dash minus y equal to 1 plus e power minus x power minus 2. Consider it as equation 1. We can write y double dash as d square y by dx square minus y equal to 1 plus e power minus x raised to the power minus 2. And we can write d square y by dx square as capital D square y minus y equal to 1 plus e power minus x raised to the power minus 2. Now take y common from the two terms of LHS. We will get d square minus 1 into y equal to 1 plus e power minus x raised to the power minus 2. Consider as equation 2, which is in operator form. Say f of d into y equal to some function of x, where f of d equal to d square minus 1 and r of x equals to 1 plus e power x raised to the power minus 2. Now we'll find the solution, the general solution of equation 2 and equation 1 using y equals to yc plus yp. We'll find yc using the auxiliary equation, and later we'll find yp using yc. Okay, and few formulae. Here we have r of x equals to 1 plus e power minus x raised to the power minus 2, right? Or we can write it in fraction. So let's see that, and later we'll go for yc and yp and the general solution. Okay, we have r of x equals to 1 plus e power minus x raised to the power minus 2, right? And we can write e power minus x as reciprocal of e power x. So let's replace e power minus x with 1 by e power x raised to the power minus 2. Now take the LCM of the two terms. We'll get e power x plus 1 by e power x raised to the power minus 2, right? Now we can split the total expression as e power x plus 1 power minus 2 by e power x power minus 2. We know that e power x whole power n equal to e power n x, so we can write the denominator as e power minus 2x. Now let's split the fraction as 1 by e power minus 2x into e power x plus 1 power minus 2. Since we know that reciprocal of e power minus 2x can be written as e power 2x into, and we know that x power minus n is 1 by x power n, or a power n equals to, a power minus n equals to reciprocal of a power n. So we can write e power x plus 1 power minus 2 as, just consider e power x plus 1 as a, then you can write a power minus 2 as 1 by a power 2, which is e power x plus 1 whole square. Now this becomes e power 2x by e power x plus 1 whole square, right? Therefore 1 plus e power minus x power minus 2 can be written as e power 2x by e power x plus 1 whole square, which is our r of x, right? Now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d equal to d square minus 1. Let's replace differential operator by m, so that we'll get f of m equal to m square minus 1, and the auxiliary equation becomes m square minus 1 equals to 0. Now we need to find roots to this equation. Let's write 1 as 1 square so that the LHS looks like a square minus b square form, and we can write it as a plus b into a minus b. Now equate each factor to 0. When m plus 1 equals to 0, m equal to minus 1. When m minus 1 equals to 0, m equals to 1. From this we'll get m equal to minus 1 and 1, which are real and distinct roots. The roots are real and distinct. Right? Now coming to complementary function. We know that when two roots say m1 and m2 are real and distinct, then the complementary function looks like yc equals to c1 e power 1 root into x plus c2 into e power another root into x, right? And then our complementary function looks like c1 into e power 1 root into x plus c2 e power another root into x. From this we'll get c1 e power minus x plus c2 e power x. Therefore, yc equals to c1 e power minus x plus c2 e power x. Now using this, we'll find yp. Okay, let yp equal to a, just replace the constants or parameters with functions of x, a and b, then we'll get yp equal to a e power minus x plus b e power x, where a and b are functions of x. And if you compare yp with au plus bv or yc with c1u plus c2v, we'll have u and v, where u is e power minus x and v is e power x. We'll find a and b using a equal to integral minus v into r of x by uv1 minus vu1, and b is given by integral u into r of x by uv1 minus v1. If you notice, you're having uv1 minus v1 in both the formulas, so let's begin with uv1 minus vu1. Okay, and later we'll find a, b, yp and the general solution. v1 is nothing but v dash or derivative of v, and u1 is nothing but derivative of u dash, or we can write v dash as derivative of v with respect to x minus v into u dash as derivative of u with respect to x, or u1 is nothing but derivative of u with respect to x and v1 is nothing but derivative of v with respect to x is equals to u is e power minus x into derivative of v e power x with respect to x minus v into derivative of u with respect to x. This gives us e power minus x into derivative of e power x with respect to x is e power x minus e power x into derivative of e power minus x with respect to x is minus e power x. Minus e power minus x. This gives us e power minus x into e power x minus into minus plus e power x into e power minus x. We can write e power minus x as 1 by e power x, so you'll get e power 1 by e power x into e power x plus e power x into, here also you can replace e power minus x with the reciprocal of e power x. Here e power x gets cancelled and you'll get 1 plus 1 which is equals to 2. Right? Or e power x into e power minus x can be written as e power x minus x, which is equals to e power 0, since e power 0 equals to 1, so you'll get 1. Therefore, e power x into e power minus x equals to 1. Right? Just replace e power minus x into e power x with 1 and you'll get finally uv1 minus vu1 equals to 2. Therefore, uv1 minus vu1 equal to 2. Now let's find a and b using those formulae. A is given by integral minus v into r of x by uv1 minus vu1 into dx. Here r of x is a fraction, so we'll just write the formula as minus v by uv1 minus vu1 into r of x into dx for our convenience. Okay, this is equals to minus integral v is e power x by uv1 minus vu1 2 into r of x is e power 2x by e power x plus 1 whole square into dx. This gives us minus 1 by 2 e power x into e power 2x, or just write as it is, by e power x plus 1 whole square into dx. Let e power x plus 1 be some t. Now differentiate on both sides with respect to x. We'll get derivative of e power x with respect to x is e power x, and derivative of a constant with respect to x is 0 equals to dt by dx. From this we'll get e power x equals to dt by dx. Now just bring the differential dx to LHS so that you'll get e power x dx equals to dt. Now we can replace e power x dx with dt, and e power x plus 1 can be replaced with t, and from this we'll get e power x equals to, just take this 1 to our RHS, you'll get t minus 1. E power x can be replaced with t minus 1. Okay. Now we can write e power 2x as e power x whole square, since e power nx can be written as e power x whole power n, right? By e power x plus 1 whole square into dx, or we can write it as minus 1 by 2 integral e power x whole square by e power x plus 1 whole square into e power x dx, so that in the next step we can just replace e power x dx with dt, and e power x can be replaced with t minus 1, and e power x plus 1 can be replaced with t. Now a becomes minus 1 by 2 integral t minus 1 whole square by t square into dt. Just replace e power x by t minus 1 so that you'll get t minus 1 whole square, and replace e power x plus 1 by t, you'll get t square, and replace e power x plus dx by dt, right? This gives us, so here in the integrand you're having t minus 1 whole square by t square, right? We can write it as t square plus 1 minus 2t by t, and in the numerator you're having 3 terms, and in the denominator you're having 1 term, so we can express the total expression into 3 terms. T square by t square plus 1 by t square minus 2t by t square. Here t square gets cancelled and you'll get 1 plus 1 by t square minus 2t, 1t gets cancelled and you'll get 2 by t, or you can write it as 1 plus 1 by t square minus 2 into 1 by t. Just replace t minus 1 whole square by t square with 1 plus 1 by t square minus 2 into 1 by t. Then a becomes minus 1 by 2 of integral of, 1 by 2 integral of 1 plus 1 by t square minus 2 into 1 by t into dt is equals to minus 1 by 2 of integral 1 into dt is dt plus integral 1 by t square dt minus 2 integral 1 by t dt. Now just write 1 by t square as t power minus 2, you'll get minus 1 by 2 of integral dt plus integral t power minus 2 dt minus 2 into integral 1 by t dt. This gives us minus 1 by 2 of integral dt is t, and integral t power minus 2 is minus 2 plus 1 by t power minus 2 plus 1 by minus 2 plus 1 minus 2 into integral 1 by t is log mod t, right? Now this becomes minus 1 by 2 of t plus t power minus 1 by minus 1 minus 2 log t. This gives us minus 1 by 2 of t minus 1 by t minus 2 log t. Let's now replace t since t equal to e power x plus 1. Then a becomes minus 1 by 2 of e power x plus 1 minus 1 by e power x plus 1 minus 2 log of e power x plus 1, right? Therefore, a equal to minus 1 by 2 of e power x plus 1 minus 1 by e power x plus 1 minus 2 log of e power x plus 1, right? We got A. Let's now find B. B is given by integral u into r of x by u v1 minus v1 into dx, right? Since r of x is a fraction, so we'll write the integrand as u by u v1 minus v1 into r of x dx. This gives us u e power minus x by u v1 minus v1 is 2 into r of x is e power 2x by e power x plus 1 whole square into dx. This gives us 1 by 2 integral e power minus x into e power 2x by e power x plus 1 whole square into dx. Since e power minus x into e power 2x can be written as e power minus x plus 2x, which gives us e power x, because 2x minus x is x, right? Now replace it with e power x, then we'll get 1 by 2 integral e power x by e power x plus 1 whole square into dx. Now let e power x plus 1 equals to some q. Now differentiate on both sides with respect to x. We'll get derivative of e power x with respect to x is e power x plus derivative of constant with respect to x is 0 equal to derivative of q with respect to x. This gives us e power x equals to dq by dx. From this we'll get e power x dx equals to dq, right? Now we can replace e power x dx with dq, and e power x plus 1 can be replaced with q. In order to replace e power x dx with dq, we can just write the integrand or this integral as 1 by e power x plus 1 whole square into e power x dx, right? This equals to 1 by 2 integral e power x plus 1 can be replaced with q. We'll get 1 by q square into e power x dx can be replaced with dq. Now we can write 1 by q square as q power minus 2 into dq. This equals to 1 by 2 into integral q power minus 2 dq is q power minus 2 plus 1 by minus 2 plus 1, which is equals to 1 by 2 into q power minus 1 by minus 1, which is equals to 1 by 2 of minus 1 by q, which gives us minus 1 by 2q. Now just replace q with e power x plus 1. Since q equal to e power x plus 1, then we'll get b equal to minus 1 by 2 times e power x plus 1, right? So we got b and we have a. Let's now find yp. Yp is given by a e power minus x plus b e power x, right? Let's substitute a and b here. Into e power minus x plus b minus 1 by 2 times e power x plus 1 into e power x. This gives us minus 1 by 2 e power minus x into e power x plus 1 minus into minus plus 1 by 2 into e power minus x into 1 by e power x plus 1 minus into minus plus 1 by 2 into e power minus x log of e power x plus 1 minus 1 by 2 into e power x by e power x plus 1, right? This becomes minus e power minus x of e power x plus 1 by 2 plus e power minus x by 2 times e power x plus 1. Here 2 gets cancelled and we'll get e power minus x log of e power x plus 1 minus e power x of 2 times e power x plus 1, right? This is equals to minus e power minus x of e power x plus 1 minus 2 plus e power minus x by 2 times e power x plus 1 minus, I'll write the last term here, e power x by 2 times e power x plus 1. Now write the term involving log e power minus x log of e power x plus 1. Now just simplify these 3 terms. Then yp becomes minus e power minus x of e power x plus 1 by 2. Now take 1 by 2 times e power x plus 1 common from these 2 terms. We'll get plus 1 by 2 times e power x plus 1 into e power minus x minus e power x plus last term remains the same. This is equals to minus e power minus x of e power x plus 1 by 2 plus e power x minus e power minus x minus e power x by 2 times e power x plus 1 plus e power minus x log of e power x plus 1. Now take the LCM of 2 and 2 times e power x plus 1. 2 ones are 2 e power x plus 1s, e power x plus 1 into 1, right? So the LCM is 2 times e power x plus 1. The denominator first term we are having 2, so close 2 and multiply e power x plus 1 to the numerator. We'll get minus e power minus x into e power x plus 1 into e power x plus 1 plus the denominator of the second term we are having the LCM, so we won't multiply anything to this numerator, we'll just write as it is, plus e power minus x log of e power x plus 1. This gives us minus e power minus x of e power x plus 1 into e power x plus 1 is e power x plus 1 whole square plus e power minus x minus e power x by 2 times e power x plus 1 plus the second term. This gives us minus e power minus x of e power x whole square plus 1 plus 2 times e power x plus e power minus x minus e power x by 2 times e power x plus 1 plus e power minus x log of e power x plus 1. This gives us minus e power minus x of e power x whole square is e power 2x, since e power x whole power n equal to e power nx plus 1 plus 2 e power x plus e power minus x minus e power x by 2 times e power x plus 1 plus e power minus x log of e power x plus 1. This gives us minus e power minus x into e power 2x minus e power minus x minus into plus minus 2 e power minus x into e power x plus e power minus x minus e power x by 2 times e power x plus 1 plus e power minus x log of e power x plus 1. So here e power minus x minus e power minus x and plus e power minus x gets cancelled. Minus. So you're having e power minus x into e power 2x, right? You can write it as e power minus x plus 2x, which gives us e power x. So replace this with e power x minus 2 into e power minus x. We have e power minus x into e power x, which is equals to e power minus x plus x equals to e power 0. Since e power 0 is 1, so you'll get e power minus x into e power x is 1. So you can replace this with 1, 2 into 1 minus e power x by 2 times e power x plus 1 plus e power minus x log of e power x plus 1. This becomes minus e power x is minus 2 e power x, minus 2 into 1 2 by 2 times e power x plus 1 plus e power minus x log of e power x plus 1. Now take minus 2 common from the numerator, you'll get minus 2 times e power x plus 1 by 2 times e power x plus 1 plus e power minus x log of e power x plus 1. So here 2 gets cancelled and e power x plus 1 cancel. You'll get minus 1 plus e power minus x log of e power x plus 1. Therefore, yp equal to minus 1 plus e power minus x into log of e power x plus 1. Let's now write the general solution using y equal to yc plus yp now. Therefore, the general solution is given by y equal to yc plus yp. We have yc, c1 e power minus x plus c2 e power x, and yp is minus 1 plus e power minus x log of e power x plus 1. This completes the problem. So we have seen a problem from variation of parameters method in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.